Everyone, so today we will be solving another interesting problem number 61, rotate list. The problem says given the head of a linked list, rotate the list by k places to the right. Okay, so looking at the problem, the intuitive approach that comes to mind is we have the list like this. Okay, and after two rotations the list would become like this. So what we can do to solve this problem is the first very thing. So the first thing that we can do is we can find a pivot node where we want to do the rotation. So that's the very intuitive thing that comes to me. And to find the pivot node, what we can do is we can traverse this linked list till the end to find the length, and we are given k is 2 and we want to rotate the list to the right by k places. So we can calculate the pivot node by subtracting k value from the right. So this would become our pivot node, and once we have found the pivot node, what we can do is we can do the rotation at the pivot node. So what we can do is once we have the pivot node, we can reach to the pivot node by using a node just by traversal. So we'll use one node called tail, and we can use this node to reach till the pivot node. And once we are at the pivot node, we can break the connection of this region on the right and name this new region as new head, and break the connection and put this connection in the beginning of the list. So we'll bring this whole connection from the right to the beginning of the linked list. So we can bring it over here, this will be over here, and this next will point to the none at the end. So this way we can rotate our linked list in just one pass. So yeah, so this is my initial approach, and let's see how we can write it down. So the very first thing that I want to do is we need to get the length. So for that we will keep one tail node and length variable. Tail will keep at head and length will start from 1. So we'll traverse the list to calculate the length, and every time we are passing over one node, we'll increment the length by 1. So we have the length now. Now what we can do is we'll again put this tail node at the beginning of the list. So we'll circle the list, which is tail dot next is equals to head. Now what we need to do is we need to find the pivot. So how we can find, like we discussed, that we can just subtract it k from the length. So one thing that I noticed that k could be bigger than the length of the linked list. So to bring it within the limits of the length, we can modulate it with the length so that k remains within the boundaries of the length. And we have the pivot node. Now we need to position our tail node to the pivot that we have found. So for that we need to traverse till the pivot and bring our tail node to the pivot location. So that's how we reach to the pivot location, and now we need to do the rotation like we discussed. So we'll have the new head at tail.next, and tail.next will break the connection and point it to the none, and at the end we'll return this new head, right? And one more thing that I observed is k could be 0 and also the nodes could be 0, meaning basically it could be something like this. So if we have nothing is there, if we have an empty list, basically we have 0 nodes, so we have to write one edge case for that. So which would be nothing but simply if head is none or head dot next is none, or our k is 0. So in that scenario we just want to return the head. Okay, so let's run our example test cases and let's submit our code. Okay, so the code is running pretty fast, it's good, amazing, and the time complexity for this would be O of n because we are doing everything in one pass, and the space would be just O of 1 because we are not using any space. So yeah, that's how you solve this problem. Thank you.